Where and when calculating motion. Remember from our CART lab that if something moves a particular distance in a certain amount of time, and it moves that distance in equal intervals of time, then we can calculate the slope of the distance versus time plot. In this case, a rise of 50 meters divided by a run of 5 seconds. In other words, we're taking the distance dividing by the time here. We would end up with the object speed. So in this particular case, since we have a constant slope here, we're going to have a constant speed of 50 meters over 5 seconds, or 10 meters per second. So that is our speed equation. Speed is equal to distance divided by time. Let's see how we use that speed equation in solving problems. In our 7 steps for problem solving, remember that we read the problem twice, the first time just to get a general feel for things. So a runner runs a 100-meter race in 12.2 seconds. What was her average speed? So now the second time we read it, we look for our knowns. A runner runs 100 meters, and meters is distance, in a race in 12.2 seconds, and seconds is time. What was her average speed? And that is our unknown, and we label that V equals question mark. Then our next step is to put that concept in an illustration here. So we show the runner, we show the distance that the runner ran, 100 meters, and we show the overall time interval, 12.2 seconds. And our question, which we show as a velocity vector here, is what is the speed? Next we do our KUF, our knowns, unknowns, and formula, and we bring down our knowns here from above. D is equal to 100 meters, and T is equal to 12.2 seconds. And our unknown, which is the speed. And therefore we can find our equation, V equals something with a D and a T in it. And the equation that makes sense, the one we're learning about here, is V is equal to D divided by T, or 100 meters when we do our plugins divided by 12.2 seconds is 8.2 meters per second. And that was her average speed. So we've been talking about speed, we've been talking a little bit about velocity. So what is the difference? A speedometer in a car will tell you what the instantaneous speed is of that car. So a speedometer tells you the speed. If you also included with that speed, you included a direction, then we have velocity, because velocity is both speed and direction. Speed is the amount of the velocity vector. How about distance? Well, we can start off with our speed equation here, and we notice that we have distance within that speed equation, and we can solve for distance in terms of speed and time now if we can get distance by itself. To do that, we need to get rid of the t here, which is dividing, so we multiply to get rid of it, and whatever we do to one side, we have to do to the other side, and these times cancel, and we're left with distance on this side. So we just flip-flop this, and we can see that distance is equal to speed times time. So now let's take a look at another 7-step problem here, now solving for distance. A car averages 42 miles per hour for a 1.5 hours. How far did the car go? So a car averages 42 miles per hour, so that's the speed, for 1.5 hours, and hours is time. How far is a distance, did the car go? So we draw our illustration, show our time interval of 1.5 hours, show our speed as a velocity vector here, 42 miles per hour, and then show what we're interested in was this overall distance, d equals question mark. We put down our knowns, unknowns, and formula here. Our knowns from above, 42 miles per hour is the speed, 1.5 hours is the time, and therefore if we're going to find d equals something with a v and a t in it, we're going to use our distance equation that we just derived. D is equal to v times t. So we take our speed, 42 miles per hour, and multiply by 1.5 hours, and there we go. We get our 63 miles. And finally, time. We have one more variable that we can solve for. So starting with our distance equation, and we want to solve for time, I need to get rid of speed, so it's multiplying. So I do the opposite, which is divide. And whatever I do to one side, I have to do the other. And the velocities cancel. We flip-flop this, and time is equal to distance divided by speed. And our last 7-step problem here, trying to find time. A plane averages 500 miles per hour, that's the speed, for a 2,000 mile flight, that's the distance. How long was the plane in flight? And that is the time. And so now I can draw a nice illustration of that, showing our time interval, but that's our question. We know what the average speed was, and we know what the total distance was here shown. And so we do our KUF. This time, speed is 500 miles per hour. The distance is 2,000 miles. And time is what we're looking for. So T equals something with a V and a D. And there we have our formula that we just derived. So 2,000 miles divided by 500 miles per hour is 4 hours. The hours flips up into the numerator here. So that was a 4-hour flight. And Scratch's parting idea here. And good luck on your quest for continuous improvement.